This is one of the most asked SRE interview question, and most of the candidates fail not because they don't know the answer, but they don't structure the answer. So in today's video, we'll see how we can structure these types of questions. And let's get started. So our first question is, it says you're an on-call SRE and suddenly an alert comes, then it says the latency increased from 100 milliseconds to 3 seconds. So what will you do? So as soon as this question or this alert stuck in your mind, what you will think? You can think a lot of things happening simultaneously together. So at times it becomes confusing or challenging how to rephrase the answer. So I have developed a simple mechanism to remember this, and I call it as IMACR framework. So IMACR stands for impact. This says what is broken, who is affected, global origin, the radius of affection, and what are the users impacted. All users are a subset of users, right? Next is matrix. M stands for matrix. What are the metrics available? A stands for alerts, anomalies. What was fired? Is it real or the false positive? Or were there any monitoring spike? And C stands for changes, any recent deployment or not. And R stands for resolution. And yeah, so let's go back to the question again. So it says you are on call SRE and you see the alert. What will you do? Answer this question. Just remember the IMACR framework. So first we need to understand what is the impact. So the role of SRE is to resolve the problem as soon as possible. It may be temporary fix as well and the permanent fix as well. So as soon as the first priority needs to be to resolve it, right? So in order to resolve it, we need to understand the impact first. So once we are aware of impact, whether it's regional or global or specific set of user or specific set of service like that, after that we need to check the alerts, like checking the latency metrics. If latency is slow, then obviously we need to start with latency first, right? And if you talk about latency, it is P95 or P99. So we'll see this as well, and we will also check for error rate spike, and check for recent deployments, like we can see it in this framework, right? Next, then based on these things, we need to understand, we can figure out where exactly the issue is. Then we can isolate whether it's app issue or infra issue or traffic issue, right? Next, let's go one by one. When we say latency, so there are two types majorly. If you talk about production ones, most of the cases. So let's say it, what type of latencies, whether it is P95. This says 95% requests are faster than this value. We more thing I would like to clarify. When we say latency 3 seconds, so that usually means average, right? And average can lie. So that means when we have the alert for latency 100 millisecond to 3 seconds, that doesn't mean all the requests are all the requests are having latency of 3 seconds. So we need to classify the type of latency, whether it is P95 or P99. So for example, if it is P99 latency, means 99% of requests are faster than this value. Means we have suppose 1000 requests, then 10 requests are having delay, right? So this means the time at which 99% of requests complete on time, so without any latency, right? So when P99 latency high, means slowest 1% of requests are very slow. That is on average 3 seconds what we receive alert for. So if P99 latency is low, means we have even slowest requests are fast, means no issue at all. So okay, this is all about the latency. Now let's go to the next concept, error rate concept, right? So this says, so actually we are breaking down the issue. We spoke about the impact, right? Now we are talking about the matrix. So this is the real world scenario, how we troubleshoot, how will we segregate the issue, right? So next is error rate. So it says out of a total request, how many requests are failing. So for example, we have 100,000 requests and fail requests are 200, then error rate is going to be 20%. So again, what type of error it is, whether it is server issues like 503, 502, and then it is critical one. And if it is 401, that may be related to client, maybe some cache or not able to reach out to some client issue, your laptop, user's laptop and issue, right? So that may not be critical. So next we understood the P99 latency, P95 latency, and what are the tools for monitoring. We need to understand the tools as well, right? So we have Prometheus, Grafana, Google Cloud Monitoring, Datadog, and various other tools. So if you talk about Google Cloud Native, so it is going to be Google Cloud Monitoring, and we have the third-party tools as well, right? Next is Okay, so we got to figure out like what are the things we are going to check. First, we will check the matrix, right? And when after checking the matrix, okay. So before that, what are the first three things you will check in first 2 minutes? So let's see how we can answer it. So like the top three checks, when we say first three things, the top three checks would be, since this is latency issue, then we need to check the latency metrics, right? Based on that, we can confirm the severity. Like if it is P99, it may be less severe. Again, severity depends upon the service type of service impacted. If it is some financial transaction, which is very important, right? So yeah, coming back to matrix, so we will check P95, P90 latency, then check recent deployment. If it is recent deployment, any changes applied, then we can roll back. Next is service level metrics like CPU, memory, request rate, threads. So we can identify the bottlenecks based on the resources we have deployed. So we'll see. We have seen as of now we don't have deep VM logging, no random logging. So everything is signal driven. So that's it. That is the world of SRE. So they are based on alerts, monitoring, and signal. So they used to log into the machines at last resort when they need to troubleshoot deep down. So first problem is to understand the problem, then try to apply the fix. When they don't fix it permanently initially, the first goal of SRE is going to be to make the client to resolve the issue at client end, to resolve the issue, not permanently fix it, but based on the further inputs and analysis, they will be applying the permanent fix or asking for the and or coordinating with a different team to fix it. Now, next question is again feedback based. So we checked P99 latency is high, error rate is normal, no recent deployment. So this says error rate is normal and no recent deployment. Then what is going to be the issue? So this indicates since this is P99 latency is high, but error rate is normal and no recent deployment as well. So this means the latency issue where the subset of requests are slow, but the system is still serving successfully. So only a piece of certain number of persons are impacted, right? So in that case, what could be the possible causes? So again, these are possible causes only. So we are not since we are not sure, we cannot say this may be the issue. So possible causes, I mean hypothesis driven issue, contemplation can be there. So the possible causes could be resource contention like CPU, memory, thread pool, slow downstream dependency. So downstream dependency, it is like other than infra. For it could be database, application, API, or some third party applications, and it could be uneven load distribution at ELB and traffic spike at few nodes. So this may be also the reason that we have the underlying resources and their resources had hit high. So in those cases also the spikes, the latency can be higher. So the practical steps can be check per metrics, per instance metrics, check dependency latency, and we can also check the load distribution. And based on that, we can isolate the problematic nodes. So so far we understood how we can tackle the question, like, and how we should not do. So that is also important. Like, don't jump into specific cause without the proof. So everything is matrix driven, right? Everything is alert driven, data driven. So um, we should not jump to the conclusion without any solid proof. So don't give unclear action, don't say risky action before like stopping service or blindly. So we cannot say like, okay, so this node has this issue, we should simply restart the service. So again, this is not advisable in production, and we don't know the dependency of the application, right? All right, so now next set is what's happening few instances the overload, P99 latency. So in this case, immediate action could be traffic drain from unhealthy instances. So now we got to know that these are few instances where we are seeing high P9 latency. Reason could be anything like resource crunch, resource high utilization, or some other internal issues. But in that case, so first idea is to task is to fix this. Okay, you identified this is the problem, right? But we need to fix it. So we are not going to restart the service, right? So the best idea is to drain the traffic to healthy instance. So the VM is unhealthy, for example, if you have the VM, and restart if needed, scale up new instances. So these are the options. So the first is going to be reroute the traffic to the healthy instances. All right. So then we have the system stabilized. Again, this may have the repercussions that if we are routing the traffic to a healthy instance, so then they also get overloaded, right? But that is, again, we need to figure out based on the inputs or based on the situation, right? So now let's see this root cause RCA. If you talk about investigation RCI, so why CPU is high, traffic imbalance, memory leak, insufficient query. So if you see, I mean, if you talk about load, high load, right, on the specific instance where we see the instance went healthy and due to some high CPU uses, in that case, we need to figure out why CPU went high. Was it some traffic imbalance, like a specific node has or a specific instance got high number of traffic, or was it a memory leak, or was inefficient DB queries? There may be a number of reasons, right? So now, so we got the root cause of what could be the root causes, right? Now, how to prevent it? So the prevention is could be auto scaling, better load balance if it is not the case, best case, alert for saturation. So we need to put the alert on saturation so that even we can also look for self healing so that it can take actions automatically. And we can also work on fixed code process if it is not efficient, right? So the think pattern is always think about first stabilizing the system, then investigate and put the guardrails to prevent the action going forward. Okay, so now next thing is next use case is CPU is normal, memory is normal, instance are healthy, no deployment, that is also fine. But P99 latency is still high, error rate is normal. Now what will you do? That is again. So we have seen these parameters and in previous use cases, and based on that we have suggested that what could be the issue. Right now these are all fine, and P99 latency is still high. What could be the root cause? Now, answer is like how this means that there is no issue at infra. I mean, whatever the infrastructure we are deployed where the application is running, so there doesn't seem to be any issue. So the latency is likely to coming from downstream dependency or external call that is outside or beyond infra. So now what? So let's understand the possible causes. So when we say external call or downstream dependency, so that is beyond infra, and the possible causes could be slow database query, external API latency, cache miss network delays. There could be a number of reasons, but how to figure out which one is the main reason first, right? So in order to get that, we need to understand, we need to trace the distributed tracing log to identify which part of the request is slow. Now the question is, what is distributed tracing? So let's take example. So if you are going to make some payment, right? So what happens? So you log into the server, sorry, you log into your mobile banking app. You what do you do? You scan some barcode or put some numbers or put some payees to transfer the money to, right? So and you can put the amount, you can select the source account where you will be transferring the money, and you can hit the pin code or whatever the ID or credential is, and it is going to authenticate some OTP if it is there. Then it gets transferred to the beneficiary, right? So there you can see there are a ton of process, like 7 to 8 steps, right? So even we can see these steps, right? But in the backend there may be multiple steps, like they will be communicated to the banking server, then we will in the midway there will be some payment server, payment gateway, so there will be a lot of more steps. So what distributed tracing does, it keeps track of every span. So there will be multiple hops where the application will be processing the data, right? So it distributed tracing keeps a log of each and everything, how much time which operation took how much time, right? So with help of this distributed tracing, we can exactly find out where exactly what was the delay, what was the latency was on what step, and based on that we'll be able to take actions. So we didn't so coming back, we can see system layer debugging. We can see this like infra CPU memory app is threads logs dependency DB API, right? So now we have downstream dependency. This is service component that your application depends on to complete a request. So yeah, so the application dependency is here, and we have external call. So this means call to microservices or third-party API. DB cache, for example, you have an application that makes payment, then it will reach from, you can use some mobile app, and then it will connect to banking servers and gets transferred. So if you talk about mobile app, third party app, for example, let's take example of Paytm. So it doesn't have a bank, right? But it does communicate with the bank. So for Paytm app, bank is going to be a third party API, right? So this is the fundamental concept. And we spoke about the tools, right? So it is Grafana, Datadog, so Google Cloud Monitoring. Okay, so if we talk about cloud uh, distributed tracing, so Google does have the tool called Cloud Trace, which keep track of the complete cycle of an operation or request. All right, so that's it for now. See you in the next video. Thank you. Bye bye.